All right, good morning. This is going to be Objective 1-2. We are going to simplify radical expressions, and we just talked about when I use the word radicals, I'm talking about square roots, cube roots, fourth roots, fifth roots, sixth roots. We're going to specifically talk about square roots and cube roots in this class. If you're going to Algebra 2, you'll get into fourth roots and fifth roots and sixth roots and seventh roots and so forth and so on. Okay? But once you know how, like, the process of simplifying, and I might even show you a fourth root or a fifth root or a sixth root, because if you can do square roots, you can do cube roots. And if you can do cube roots, you can do fourth roots. It's all the same process, okay? So a radical is an expression that has a square root or a cube root, okay? Notice here, if it has no number on the outside, it's understood to be what? Square. This is understood right here to be a square root, okay? Otherwise, it'll have another number. So if it's a cube root, it will have a 3. If it's a fourth root, it'll have a little 4. If it's a fifth root, it'll have a little 5, okay? But if it has no number, it's understood to be a square root. Any questions on that? Okay, so we're going to use prime factorization. You learned prime factorization probably 5th or 6th grade. Anybody remember what prime factorization is? Like if I say, write the prime factorization of 108, what would you do? Sort of, we're going to break it down till it's all prime numbers.
Right.
Yes, you're right. It's like a tree. We're going to do a factor tree. That's what prime, this is what that means. Factor tree. Okay? How many remember factor trees? Good. Okay, so the good thing about prime factorization, like if I say what divides into 108, some people might say what? 8, okay. Some people might say 2. Some people might say 3. Does it matter where you start? Good. So that's the good thing about, like, take your calculators and take 108 and divide by something so that it goes evenly. Obviously not 5 because it doesn't end in 0 or 5, but what do you want to divide 108 into? Divide it by something. Okay, so what is it? 4 and 27. Sure. Okay. Then the good thing about prime factorization is, like, everybody, you'll get a big number and you'll be like, oh my goodness. But the minute you start to break it down, what happens to it? It gets smaller and easier. And that's why we like to teach it this way. Okay. So 4 can break down into 2 and 2. Now, here's what I want you to do so that you do not miss a piece or a part. Okay. Can 2 break down? No, that means 2 is prime. It can't be divided other than by 1 in itself. So once you get as far as it can go, I want you to circle it. I don't know why that did that, but we're going to circle 2 and we're going to circle 2. Okay, 27 can break down into 3 and 9. So tell me about 3. It's done. And 9 can break down into 3 and 3. So if I wanted to write the prime factorization of 108, I would write 2 times 2 times 3 times 3 times 3. Okay? And here's the big thing, because we're going to check ourselves and make sure we're right. How do I know that this is correct? What could you do? Yeah. Multiply all that together. Multiply 2 times 2 times 3 times 3 times 3. What should that equal? 108. Do it. Multiply it. Check it. 2 times 2 times 3 times 3 times 3. Okay. Number one mistake in using this method is that, like, you'll break it down. Like, let's say you break this down into 3 and 3, and, like, you forget this little guy. Like, you'll forget one of them. Does that make sense? So it's very important when you get done with it that you take a minute and you times it back together to make sure you're right. Okay? All right. So let's actually get into simplifying the radicals. Okay? I want to simplify the square root of 392. The first thing I want you to do is in your calculator, you're going to check to see if it's a perfect square root. Okay, like, do you know how to put in a square root in your calculator? Second x squared. Anybody not know how to put it in? Okay. Try 392 and tell me, does it come out evenly? No. Okay, so at that point, if that doesn't work, you with me on that? If that doesn't work, you're going to do a factor tree. So take a minute. I'm going to pause the video, and I want you to factor down 392 for me and tell me what you get. So what are we breaking 392 down into? Brandon, go. 8 and 49. Anybody else do 8 and 49? No? Does 8 times 49 work? You sure? I'm trusting y'all. I don't have a calculator. So when I ask questions, I'm trusting y'all to like help me out and just double check. Okay? So it does work. I hear a second. So sold. Does it matter if you didn't do it this way? No. Okay, let's just make sure in the end that we all get the same answer. So we can break 49 down into 7 and 7. What do we know about 7s? They're prime. Okay. And then 8 can break down into 4 and 2. What do we know about 2? It's prime. It's done. And then this can break down into 2 and 2. So if I wanted to do the prime factorization of it, I should have 3 2s and 2 7s. Yes? Yes. Everybody get that? Any questions on that? Okay. So what we're going to do to simplify this, I'm going to take my prime factorization and I'm going to write it underneath. Okay, I think of this kind of like Go Fish. You may ever play Go Fish? Like, do you have any 3s? And you're trying to make matches, right? So because this is a square root, we're trying to take groups of 2. So I have a group of 2s right here, and I also have a group of 7s. This 2, once I have a group, they can come to the outside of the square root. Okay, but when it comes out, let me ask you this. When we're playing Go Fish, would I count that as I got 2 matches, or is that 1 match of 2s? So when it comes to the outside, it comes out as a set of 2s, like 1 set of 2s. So it only comes out as 1 2. Do you understand that? That's just 1 match. And then I can also take out a 7. What's going to be left underneath? A 2. What do you do with the 2 and the 7? You multiply them. Okay, let's talk about how we're going to check this. Okay, because I'm not into, like, we're going to teach, and then we're going to test, right? And your test grade-ish is going to be a big portion of your grade in this class. So we need to make sure we're doing it right, correct? Like, I'm not going to load you up with, like, 50 problem tests. I'm going to load you up with, like, I don't know, 15 to 20 questions on a test. So I want you to take time and check. So let me show you how to check. Put in the square root of 392. You're going to get a decimal. Everybody do that for me. Put in the square root of 392. Now put in your answer. 14 times the square root of 2. What should happen? They should be the same thing. Because we're not changing the problem. What have we done? We've just simplified it. Like, for example, let me take you something simple. 4 over 8 reduces to 1 over 2. Everybody agree? If I divide this in the calculator, I'm going to get 0.5. If I divide this in the calculator, I'm going to get 0.5. Even though they look different, they are the same. They've just been simplified. This is a simplified version of that. Do you understand that? So you can put in your question, you can put in your answer. They should be the same. All right. So step 1, let's check to see if it's perfect. First of all, can you put in square root of x cubed? I mean, you can put in an x, but it's not going to be right. So you can only put in the numbers. You can put in square root of 252. Is 252 perfect? No. So what we need to do is we need to break it down. What can 252 break down into? Anybody? 6 times 42. 6 times 42. Okay? And 6 can break down into 2 and 3. What do we know about 2 and 3? They're done. Okay, and we're going to circle them so we don't lose them. Okay. 42 breaks down into 6 and 7. 6 breaks down into 2 and 3. So I've got a pair of 2s and a pair of 3s. That's it? Don't forget, like, make sure you circle every piece. So from here, we are going to take our prime factors and we're going to put them under the square root. And when I do it, I put them in a certain, like, let's be organized about it. Don't be like my son. Let's be organized about it. Okay? So, what would be a smart way to put these under the radical? 2 times 3 times 2 times 3 times 7?
3 times 3 times 2 times 2 times 7.
Sure. Group them. Okay? Then we're going to play Go Fish. We're going to look for groups of 2. So I got a pair of 3s and a pair of 2s. What about this x cubed out here? What's the prime factorization of x cubed? How many x's is it? So x times x times x. Okay, so do I have a group of 2s? Do I have a match? Yep, I can circle those 2. Okay, so when the 3 comes out and the 2 comes out, what does it come out with? Comes out as 1, 3, and 1, 2, which makes 6. Is that okay that I did that? And I can take how many x's out? 1 pair, so just 1 out. Does that make sense? What's the number one mistake here? That people would take out like 2 x's, like an x squared. Does that make sense? If you circle it, it only comes out as 1. Okay, that's 1 pair. What are you left with underneath? 7x. Now, you cannot check your x's. You can't check your x's. But you could check your numbers. Like you could put in the square root of 252, get a decimal, and then you could put in what? 6 and square root of 7. And it should be the same decimal. Any questions on that? Okay. How about you do this one on your own? See what you get. Okay. Let me help you out. With whatever you take here that comes to the outside, you with me so far? What are you going to do with that 3? You're going to multiply. Okay. All right. So, I'm going to show you something, okay, because I'm all about making math easy. I used to have one of those Staples easy buttons. I need one. It like died. But anyway, that way I could hit it and be like, you know what I'm talking about? That was easy. Y'all know those? Okay. Are you sure? Anyway, but what did I tell you always to do first before you go straight into factor treeing? Just put it in. Put it in square root of 36. Do you understand that? Square root of 36 is perfect. So it's 6. So he could just come straight out here and be a 6. Ah, you get what I'm saying? Always, always, always check to see if it's perfect. Now, here's my question. Those that factor treated down, did you still get a 2 and a 3, which made 6 on the outside? Okay. So, at that point, I can break x cubed down into x times x times x, and then y times y. Not that. I can't get it to go up now. There we go. Y times y times y, and I can circle a group of x's and a group of y's, so that can come out and that can come out. So 6 times 3 would be 18 with 1x, 1y, and then notice what do I do? Like, there's a couple little things so that you don't miss pieces and parts, okay? Like, the bad thing about math, and that's different than other classes, is like in English. And they ask you your opinion, you know, of the story. And if you, like, kind of get in the general area, you get some points for that, correct? The bad thing about math is if you miss one little piece or part, the whole thing is wrong. It's wrong. Okay, so notice there's a couple things I'm doing here. What am I doing to make sure I don't miss any pieces and parts? I'm circling and I'm underlining. Like when I circle what's coming out, how many are circling and like actually drawing arrows that it's coming out? It will direct your eye of what you're doing. When you don't circle, especially when it gets really, really long, you're going to mess up. I'm just telling you, you're going to mess up, you're going to miss a piece part, and then you might get like most of it, but you might miss one little detail, okay? But come test time, if your test is in IA, it's wrong. Like, what if it's like you have to drag how many X's and Y's go which way? You know what I'm talking about? And you miss a piece, it'll count it wrong. So just make sure you do that, okay? All right, try that one. All right, 288 breaks down into 36 and 8. 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. 36, I'm going to do 6 and 6. And then 2 and 3. And then 2 and 3. And here's what I'm telling you. Like this would be, if I had this one on the test, what would I make sure that I do? And multiply it back together to make sure that I did all of that correct. You wouldn't believe how many people take 6 and 6 and break it down into what? 3 and 3. And I get where they do that, but you see what I'm saying? Like, we're human. We do things in our head. It gets jumbled up. We make easily mistakes. So I would double check and make sure that it becomes 288. So 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5 twos, and 2 threes. Whoa, that's really weird. That's okay. We'll leave it at that. And then this will be 4 X's. I'm going to do something slightly different because tomorrow we're going to look at some that are a little bit bigger than this. So we're going to learn something. You can write it out. X times X times X times X and circle groups if you want to. But what if it's like X to the 19th? You want to write 19 X's? Okay, so this is, I'm going to lead you into what we're going to do tomorrow. So we're going to take out, like, what I'm going to do is I'm going to say, we're going to divide by the root. This is a square root. Let's try this one more time. This is a square root. Is 4 divisible by 2? So then I'm going to leave it right here as x to the 4th. He can come out, and I'm going to divide him by 2 when he comes out. Y is just y. And z squared, is he divisible by 2? So I'm just going to leave him as z squared, and I'm going to show you how I take it out. Just slightly different. So you may like this way better. So I'm going to circle a group. There's a group. Why does it have, this should be a 3, right? 1, 2, 3, 4, 5, and 2 threes. I don't know why it changed it to a 5. And then this is perfect. This is not going to let me write. Come on. This is perfect, and this is perfect. Just a couple more seconds. Really? All right, so that comes out as a 2, and a 2, and a 3. And when you multiply all of that with negative 2, you get negative 24. I give up. It's not going to let me write. Negative 24. X to the 4th comes out. I'm going to divide this by 2, so it comes out as x squared. Did you see how I did that? This comes out, I'm going to divide him by 2. It comes out as 2 divided by 2 would be z to the 1st. You with me so far? What's left underneath? A 2 and a y. How many got it?
I thought it was saying y and u was squared.
Oh, gotcha. I gotcha. We will